All right, I wanted to go over activity one, the first part and the second part, and sort of narrate the way that I work through the solutions in case you want the additional insight over kind of how I construct the commands to help you out here. So the very first question deals with just evaluating expressions, basically using R as a calculator. So in each of these expressions, we're going to take x to be equal to 1/2, and then evaluate the things on the left-hand side of the equal sign. And we'll know we'll get the right answer when we are able to reproduce the number on the right-hand side. So the first part says to define x to be equal to 1/2. So R lets us define variables with the left arrow convention. Basically, if I'm going to define a variable, I'm going to give it a name, and in this case x, followed by the left arrow symbol, which is really the less than sign and then a dash right next to each other. And then whatever expression I want to define the variable as. And in this case, I'm just going to write out 0.5. I could have it as 1/2 if I wanted to, but 0.5 it is for me. And now I want to evaluate the expression x squared over x minus 1. So to square a number, I do the caret symbol, which is shift 6. X squared looks like that. And now I'm dividing by the quantity x minus 1. So I need to wrap x minus 1 in parentheses so that the subtraction happens first, and then I divide x squared by the result of that subtraction there. And so if I go ahead and run these lines of code, I'll click Run. You'll see that x is now defined in the Environment tab here. And then evaluate this expression. Sure enough, it evaluates to minus 0.5, so I know I must have done that correctly. So I'll go ahead and knit the HTML to update my work, and so I see that the R code is automatically included, and the result of running the R code is also included there. That's why I really like the markdown format. Okay, so part B asks us to evaluate the expression e raised to the minus 0.7 plus 1.2x divided by 1 plus e to that same power. All right, so this is a relatively involved expression. Let's start out with the numerator. If I'm going to take e and raise it to a power, the way that I do that in R is with the command exp. I can't just take e and then do the caret sign because e actually responds to or refers to scientific notation. Okay, so e to the minus 0.7 plus 1.2x divided by, and now I have two things in the denominator, so I want to wrap that in parentheses, 1 plus e to the minus 0.7 plus 1.2x. So here I've actually typed this out so that there is an error, and in fact R is able to anticipate that, hey, this is a bad line of code here. If I try to run this line, it'll come up with an error that says unexpected symbol. Remember the way that R works is that whenever multiplication is involved, you actually have to explicitly put that multiplication sign in there for the command to be evaluated correctly. So even though we can look at this and we say, oh, well, that's minus 0.7 plus 1.2 times x, I actually need to put in that 1.2 times x in order for it to evaluate correctly. So this thinks it evaluates to 0.475. That's the same number, so I'm good to go. All right, so I'm going to delete this comment here. You'll notice that I didn't have to start out this chunk of R code by defining x to be 1/2 because I already did that earlier on in the document. When our studio compiles the RMD file, it basically extracts all the R code and just runs it one line by line sequentially. So I don't need to have kind of each chunk be starting anew. It's going to keep track of previous results as well. I'm going to delete this. All right, the logarithm base 10 of the absolute value of the natural log of x. So R refers to log base 10 as just log 10. And then inside the log 10 parentheses, I want to put the absolute value of the natural log. Well, the absolute value function is just ABS. And then what am I taking the absolute value of? Well, I'm taking the absolute value of the log of x. Now, R refers to the natural log as just log. Log base 10 is log 10 here. So I'll be good to go. I can press return or run, and sure enough, it evaluates that expression. All right, so key things to remember when writing out expressions in R is to make sure your parentheses are correct, that they're balanced, that you have equal numbers of left-hand ones and right-hand ones. And one nice thing I like about R is that as you close off the parentheses, it automatically highlights which one that's matching, so you can easily tell if your parentheses are mismatched. And then also make sure your implicit multiplication symbols are there. Okay, question 2 asks us to study the customer transaction data set here. Now, in order to read in the file, I need to make sure that both the activity1.rmd file and the file that I'm trying to read in are in the same location. And so that's why I've recommended making a BAS 320 folder where you just put everything over the course of the semester. Now, if you're a bit of a neat freak and you want a separate folder for every assignment, you can feel free to do that. The key thing is your RMD and your data files need to be in the exact same folder. Otherwise, you're going to get errors when you try to compile your documents. So let's say that you're not exactly sure if you're in the right folder. Well, you can go into Session, Set Working Directory, and choose the directory to be where both those files are. So in this case, I'm actually not in the folder that I'd really like to be in, so I'm going to go to my BAS 320 folder, and I've actually put this assignment into the Activity1 files. So I'm going to click Open here, and I see that the data file is there, and the RMD file that I'm currently editing is here as well. So, all right, how do I import this data frame? Well, one thing I want to do is come up with a name for the data frame first, and I suggest cust in all caps, followed by the left-hand arrow because I want to define cust to be that data frame. And we're going to read that in by using read.csv. Now, inside the parentheses, I want to put the name of the file in double quotes, and I'm going to go ahead and just copy and paste that right here. And when I click Run, I see that the data is now present in the environment panel, meaning that, yes, I have correctly read in this data frame. Okay, I'm asked to determine the number of rows and the number of columns. Well, I can easily do that by just glancing over here. There's 1,631 observations, which corresponds to the number of rows, and there are 10 different variables in the data set, meaning there's 10 different columns. So if I want to print out the first 4 lines to the screen using head, I can do that. Head is a function that prints out the first few lines of a data frame or the first few elements of a vector. All I need to do is specify as the first argument what I want to be printing out and then the number of lines. So head comma 4, when I run that, I see indeed prints out the very first 4 lines. Okay, well, what about a specific row, row 27? Well, I can refer to a specific row by once again typing out the name of the data frame that I want to refer to and then putting a pair of square brackets with a comma in the middle. Now the number or numbers before the comma refer to the row numbers that I want to be looking at, and the numbers after the comma refer to the column numbers that I want to be looking at. Now in this case, I want the entirety of row 27. I want every column, so I can actually leave the number after the comma just blank. So running cust27, I see that here's the information in there, and it looks like the person spent $31.40. So I can add a comment that says $31.40 to answer the question there. All right, part C, what is the column name and number that contains the customer's zip code? Well, one thing I can do is click the arrow here to get a preview of what's inside the data frame. And the customer zip code in this case looks like it's being referred to as czip in all caps, and that's the 1, 2, 3, 4, 5, 6th column in my data frame. So I already know what the answer is. I can say that this is czip, and it's the 6th column. There's actually an command that I can run to get this information more or less automatically. If I type the command out data frame and then in parentheses request the names of my data frame, what that will do is that will print out a list of the columns and also number them as well. So I see that czip is indeed the 6th column. And that's useful if there were just way too many to count. Okay, now part D says using either summary or table, find how many times this person purchased something on the internet, column internet here. So this is requesting a frequency table of the values in the internet column in the data frame here. So I can do this with either table or summary. I'm going to start out with summary. Inside summary, I want to give the name of the column that I'm looking at here. So it belongs to the cust data set. And you'll notice doing cust $ kind of turns on the referral to a particular column, RStudio will actually spit out a list of all the columns that it knows about. So I can just select from the list, or I can type it out. That's fine. Click Run, and actually I should actually use the correct column here, Internet. And it looks like the person shopped 190 times, or made 190 purchases on the Internet. So 190 Internet purchases. Table works the exact same way. The argument that you want to pass to table is the column that you want to get a summary of. So table cust $internet, cust $internet extracts that internet column, and it's the same information here. All right, make a bar chart of the industry column. Well, I can make a bar chart by invoking the command plot and just passing as the argument the vector or the column that I want to get my chart for. So once again, the way I refer to a column is by typing out the name of the data frame, $, and then either typing out or selecting from that list the column name. So I could run this, and this isn't a very useful plot. There are so many different categories here that R isn't able to label all of them, and in fact it kind of picks odd ones to label. So we can't immediately identify what's the largest, most frequently occurring category, which one's the second most, etc. What we would have to do is we'd have to run the command table to get that frequency table to figure out, okay, well, which are the more common and less common industries here. So scanning up, we know that this most common category is very near the top of the list, and so we see that this corresponds to automotive fuel. Okay. Part F says that the distance, how far that customer is away from the store, in that row we printed out earlier, row 27, looks to be a bogus value, -999. And in fact, that's the way the data was constructed. If we didn't know how far the customer was away from the merchant, then we just assigned it a distance -999 so that we knew after the fact, going back to it later, that, hey, don't pay attention to this particular row. So how do we change this value? Well, like we've discussed before, if we kind of view the spreadsheet in RStudio, we're not allowed to point and click and actually change any of the values. So if I say View Cust, that'll bring up the spreadsheet view, but I'm not allowed to do anything to it. It literally is just to view it. So in order to change anything, in order to make any edits, I actually have to be very careful with my left-hand arrow convention. In this case, I want to change the distance in the 27th row. So what I can do is I can refer to the 27th row and the distance column here. And this happens to be the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th column. So I could put cust 27, 10, or actually just refer to it by name. This works too. And then the left-hand arrow convention is going to give this a new value, whatever is on the right-hand side of that arrow here. So we're going to assign this to be equal to 2. And we can print out that row once again to just confirm that that change took place. So indeed, that distance is equal to 2 here. Okay, it turns out there's actually a lot of values in the distance column that are -999. There are a lot of merchants that we weren't quite sure about. And so we might want to make a subset of the data where we only have valid distances here, distances at least 0. So how can I do this? How can I get a subset? Well, the command is subset. The first argument is the data set that I'm going to be taking rows from, which is the cust data frame. The second argument is the condition that I want my rows to satisfy. So in this case, I want to make sure that the distance column is at least 0, greater than or equal to 0. 0 happens when they're in the same zip code. And then the third argument, if I want to give it, will select the columns that I want to keep in the subset. If I leave this blank, then it'll take every column to put in the subset. In this case, I just want the amount column and the distance column. So I say select equals, and I give it a vector of the column names that I want. So I need to make sure they're in double quotes because they're names here. And finally, I'm going to give this a name here, basically assign this subset to be called cust D for cust distance. So I'll click Run. And now what I see is that, okay, cust D is here over in the Environment tab, and I see that it contains fewer observations than my original data frame. It's filtered out those -999s, and it's only keeping track of the amount spent and the distance to the store. All right, once this is done, find the average of the amount column and then look at the summary of the distance column. Well, to get the average, we can type in mean and then the name of the column that we want, so cust $amount. And look at a summary of the distance column. Okay, well, no problem there. Make sure I don't typo it. So it looks like the average amount was about $50, and if I look, whoops. So this is what to be careful about. Always make sure you're referring to the right data frame. Here, we're only looking at the rows with valid distances. So I'm referring to the cust D data frame, not the original data frame, which is cust. It's a good thing that I did check the summary because I see that, oh, these values shouldn't be in there, so I was referring to the wrong data set. So the average of the good rows still right at about 50. And here's my summary of the distance. I've confirmed that all of those minus 999s are out of there. Okay, question 3 is one that I don't really expect you guys to do, or I don't necessarily want you to know how to do it at this point. But I will go over it just for the sake of completion. What we want to do is we want to make a vector y that's a sequence that goes from 8 to 103 in increments of 108. So I know how to do this. Y left arrow is going to define y to be something, and that something is going to be the result of running the sequence command, seq. So I start out by saying where I want it to go from. So from equals 8, 2 equals 103, and then by equals 1.8. That gives the increment that I'm doing the sequence with. So I can run this command, and you'll see that, okay, it knows about the vector y now. And indeed, 8, 9.8, 11.6, it's going up in steps of 1.8 here. Okay, now this requests using the length function combined with which, how many of the elements are larger than 90? Well, I can actually just print out this vector to the screen, and here are my elements that are larger than 90, so I know that the answer is 1, 2, 3, 4, 5, 6, 7. So how can I use R to automatically figure that out for me? Well, we have this command called which is an interesting command here. What it does is it prints out a list of the element positions in a vector that meet a particular condition. So if I say which y greater than 90, then what it's going to do is it's going to scan through my vector y, and it's going to report the positions of all of the elements that meet my condition. Which elements of y are greater than 90 here? So if I were to just run this, it would say, okay, well, it looks like the 47th, 48th, 49th, 50th, etc. positions are greater than 90. And that makes sense. So if we look, this number here in the square brackets tells you what position the very first number in that line corresponds to. So this is the 43rd position in the y vector. So 43, 44, 45, 46, 47. So that's correct. So the number of elements would be just the length of this vector. And so what I can do is kind of just put the result of running which y greater than 90 inside the length function so that it'll figure out how many elements are in there, and indeed it's 7. Okay, so I'm done. I'm going to knit the HTML, and there I have it in final form. It looks good. So that is that first activity 1.